Now it's time to look into the one example, t-SNE to analyze the word embeddings in natural language processing tasks. So we will look into a step-by-step process to perform dimensionality reduction using t-SNE on word embeddings from a CSV file, and then we will also display the reduced data or reduced dimensions of the data and upload the visualization. So the first step, as usual, importing the libraries. So these are the libraries we are going to import. So pandas as pd, numpy as np, and matplotlib.pyplat as plt, sklearn library, manifold package, and t-SNE is the module. This is what we are going to import, and these are the very important things to be done when you begin with your project. Then load and pre-process the data. So load the word embeddings from CSV file. So read underscore CSV, that's what we're gonna use. A read underscore CSV function from the pandas, and then a respective path will be given as an argument to the function. And let me execute, and here you can see the data that I have called. It's 1,000 sentences that we have. It's of course a one column because it all sentences. We have 1,000 sentences, and each sentence consists of some words such as apple, grape, orange, kiwi, peach, pear, apple, orange, banana, melon, pineapple, kiwi, and this is what the data we have. Next, convert the word embeddings, the word into the word embeddings. That's what is the most important aspect of this. Convert the word embeddings into a numpy array. So that's what we're gonna do. So we have loaded the data set. Now we have to extract the word embeddings data from the data frame. So we will use the random word embeddings. So this is what, when I see apple, this is the embedding I'm going to use. Banana, this I'm going to use. This is a simple random embedding, random word embedding. Okay, so these are the word embeddings. So now I have to convert that word embeddings and attach to that. So now it's time to do that. So if you see, I have to write a function to convert this word to word embeddings. So for that I have defined the convert to embeddings, and respective data, the sentence respective data will be given to here, and then it's going to convert that into the word embeddings. Okay, and then after that you have to apply the function to each sentence in the data frame and attach this to the uh, respective data set. So now let's look into that data. So this is how it looks. Okay, here is your sentence, and each word has been embedded, and then it's been converted into the numpy value. You see that each word apple, and this is the numpy random values. Okay, now this one has been converted embedded, and of course it's going to come up with the mean of the respective numpy array. So here you can see for each apple 0.61, and another apple 0.43, grape and pear 0.45, pineapple 0.37, apple and mango 0.66, melon 0.18. So this is what we called as embedding from a word embedding. Okay, so the word embedding has been done and it has been attached back to the data set. So now what's next? So it's time to apply the t-SNE. So apply t-SNE for dimensionality reduction of course we have to call the respective class object. We have to instantiate a respective class object here, t-SNE module. From the t-SNE module, the class name is t-SNE, capital T, capital S, capital NE, and inside the two arguments it's going to take number of components you want to make, two, and a random state or random seed is 42. Then after that you have to fit the respective data. So here X, of course I need to have only embeddings, so that's the reason I've taken embeddings. So this X embeddings will be fitted into the respective uh, this X embedding, the values would be fitted into the t-SNE object using fit underscore transform method. If you want to see X, let me show you that also. Yeah, this is how your X looks like. It's a two-dimensional array. Okay, so hence the fitting the data into the respective model is done. So model creation is done. So now it's time to look into our display the reduced data set. Now let's display the reduced data set, how these all embeddings has been reduced back to just two components. Here you see, here I have put it reduced embeddings, and then let me execute, and here is your reduced components. It's been just brought into two components, component 1 and component 2, whereas you have here these many number of components. If I show, these many embeddings has been converted into just two. You see, just two columns, just two columns. But if I take up I think let me take up the X underscore just capital X shape. So it's 5. The 5 has been converted into 2. It's 2. So this is what is dimensionality reduction. Of course, you won't have clarity what exactly, and interpretability is less and explainability is less, but still something is happening under the hood inside the black box. Okay. Next, plot the t-SNE visualization using matplotlib, and that's what we will be doing. It's a self-explanatory. So then we have plotted that, and after plotting it, this is what we got. Okay, if you want to see the labels, let me attach the labels also. I just removed the labels, and yeah. So if I put the labels, and this is what is going to happen, and you can see this is t-SNE dimension 1, this is t-SNE dimension 2. So the whole data has been plotted in two-dimensional space using t-SNE. This is the power of t-SNE visualization. On the other side, you can bring down the high dimensional data set into a reduced or low dimensional space, and this is what we have done. It's a low dimensional space, basically two-dimensional space. So that's what is our t-SNE, t-distributed stochastic and neighbor embedding. t-SNE provides powerful visualization capabilities that help researchers and data scientists gain insights into the complex and high dimensional data sets, making it a valuable tool in exploratory data analysis and data visualization tasks. However, it should be noted that t-SNE is computationally expensive and may not always preserve the global structure in the lower dimensional space, especially when the original data contains large intra-class variations. As such, it's recommended to use t-SNE as a tool for exploratory data analysis and visualization rather than a method for feature engineering and supervised machine learning tasks.